So just a quick review, recap. We've had two types of markup. If I give you the cost of an object is $56 and the markup, the percent markup, is 30% based on selling price, I want you to find the selling price. I want you to do that one quick. So, yeah, first thing we want to identify, this is on selling price. The 100% goes there. What else do we know? 30% is on the markup. Cost is 56. We are looking for dollar amount of the selling price. So obviously we need this row here. We either need to know this number. Right now there's no way to find that number. Or we need to know this one. That one we can find pretty easily. It's going to be what? 70. So that takes this middle row out of play for now. 100 times 56 divided by 70 is 80. So the selling price is $80. So let's say that we have a selling price that's $70. Our percent markup, I don't know why I wrote that all the way out, is 40% on cost. Find the cost. So start out, where does the 100 go? On the cost. Very good, because it's on cost. Good. What else do we know? 40% markup and $70 selling price. Looking for dollar cost. This number is going to become 140. Very good. So I can ignore the middle row again. 100 times 70 divided by 140 is $50 cost. So we can work with either a markup based on cost or a markup based on selling price. Hopefully at this point you're starting to get a little bit familiar with that, almost bored with it, hopefully. The key is always look for, does that say on cost or on selling price? Or sometimes might even say based on cost or based on selling price. But now it is easier when pricing an item to do a markup based on cost. If you just take a percentage of the cost and add it on, or, you know, as we'd mentioned before, if it's a 30% markup on cost, you can use 130 or 1.3, you just multiply the cost by 1.3 and you got the selling price. Really easy way to find the selling price. But on the back end, as we mentioned earlier, it's a lot easier if you know the markup based on the selling price, so you can take your total cash register receipts and just use the percent to figure out what amount of that is markup. So in practice, they convert between percent markup on cost and percent markup on selling price. And this conversion sounds complex, may even look a little complex, but it isn't so bad. Make a star in your notes, because this is one of those things that a lot of people look for later and they struggle to find it. Really, it's missed a lot on the test. But if I ask you to convert let's say I ask you to convert a 40% markup on cost to a markup on selling price. We are still going to use the same table. Cost plus markup equals selling price, with one small modification. We don't have any dollar amounts here. We don't care about the dollar amounts. all we can care is about converting this percent to this percent. So our columns in our table now, instead of being percent on one side and dollars on the other, are going to be percent on cost on one side and percent on selling price on the other. And before we fill anything else in on this table, on this side where it's percent on cost, where does 100% go? With the cost. Very good. On this side, where it's marked percent on selling price, where would the 100% go? With the selling price on bottom. Now there is one piece of information we've been given, that 40%, which side is it going to go on? It is on cost. It goes on the cost side. 40% will go right here. Now with that, we can find this number down here, which will be 140. And we're asked to find the percent markup on selling price, which is this number here, which means I'm going to ignore the top row now and just do 40 times 100 divided by 140, which comes out to be approximately 28.571426% markup on selling price. Now, if I ask you to round to the nearest hundredth of a percent, what's that going to round to? 28.57%. Very good. Any questions? Let's do another example. That one's a little trickier, isn't it? Let's do another example. Let's ask you to convert a 20% markup on selling price to a markup on cost. So our table is still cost plus markup equals selling price. And again, we're not going to be just percent in dollars. Over here, this is going to be percent on cost. And I'm just going to put the 100% in there right now. Over here, it's going to be percent on selling price, and I'm going to put the 100% in there right now. Everybody with me so far? Right. So now, what do we put in? 20% goes on the selling price side for the markup over here, which means we can find this number up here to be what? 80. Good, because 80 plus 20 equals 100. And we're looking for this number right over here, which is the percent markup on cost. So we can ignore the bottom row and cross multiply. 100 times 20 divided by 80 is 25. So that's a 25% markup on cost. Make sense? So I'm going to have you convert a 60% markup on cost to markup on selling price. So we'll start setting up our table. Cost plus markup equals selling price. Over here, again, percent on cost. And I'll put 100% in right away at the cost. Over here, percent on selling price. And I'll put the 100% in the selling price right away. Then what? $60 over here, and then we're going to add 100 plus 60 gives 160 down here, and we need to find markup on selling price over there. So we shall cross multiply and divide. 60 times 100 divided by 160 is 37.5, correct? Percent. That's a 37.5% markup based on selling price. How many of you got that? Cool. Let's go the other way. Convert 40% markup on selling price to a markup on cost. So where's the 40 going to go? Selling price side, so right here. What else are we going to fill in? So if 60 is the percent. Yeah, you got it. 100 minus 40 will give us 60 up there. And of course, we're looking for the percent over here on the cost side for the markup. So get rid of the bottom number. 100 times 40 divided by 60 is 66.67%. There we go. What do you think? Okay. Good deal. Well then. Let's talk about markdowns. Markdowns are really quite simple. A markdown can go in the same type of table if we want to, where we can have the original price, which is the normal selling price, minus a markdown gives us the discounted price. And percents and dollars again. So let me give you an example here. Let's say that after a 30% markdown, an item sells for $42. Find the original price. Well, when we're dealing with markdowns, the original selling price, I'll put original there in the selling price, is always the 100%. Here we had a 30% markdown, which means the discounted price is what percent? 70. Because it's a discount, we're going to subtract instead of add this time. And we know $42 is the discounted price. We want to know the original selling price. At this point, does everybody see why we cross off the row that we cross off? It's missing a number, and it's not the one we're looking for anyway. So then it's 100 times 42 divided by 70 gives us 60. So that is $60 was the original selling price. That is just simply a percent decrease like we did back in week 3. I'm not going to spend much time doing examples of that. What we're going to spend some time on is doing multiple markups or markdowns. For example, let's say you have a product that is original price of $80. And let's say it's a piece of clothing. And because of the nature of clothing, it lends itself to this example really well. We might have let's say it's a piece of winter clothing, and it's still sitting on the shelf right about now. What's happening to winter clothing right about now at most stores? Discount. So let's say it goes under a 30% markdown. Well, if it's still sitting on the shelf come, let's say, May, what do you think is going to happen? It's going to get discounted again. It might undergo another 40% markdown. But here's the kicker. What if it's still sitting there in October? Well, in October, winter's coming again. Winter clothing is now back in need. You might undergo a 50% mark up. Because it's now, hey, winter clothing is back in season. And let's say it's still sitting there in November or December and they realize it's just plain ugly. So they might do another 60% markdown. And of course, after that, it probably is going to go on liquidation or donated or disposed of, or an employee is going to sneak it out the back door or something. I don't know. 97-cent rack? Oh, sure. At that point, you can buy it to use as a rig to wash your car if you have to.
Well, that's when the store retains the ownership of it. So
Oh, sure. Oh, sure. So anyway, what I want to know is, after all this happens, how would you find a final price? This is where we're going to reach back a little bit to our trade discounts that we did last week. If we have a 30% discount or 30% markdown, what percent is paid? 70%. I'm going to write that as 0.7 or 0.70, however you want to do it. If there's a 40% discount or 40% markdown, what percent is paid? 60 or 0.6. Now this one's a little tricky. 50% markup means 150% or 1.5. Good. Then another 60% markdown, 0.4. 40% or 0.4. So what we're going to do is we're going to take this $80 and we're going to multiply it by all that. So 80 times the 0.7 times 0.6 times the 1.5 to mark it back up, and times 0.4 gives us a final price of $20.60. Or 16 cents, sorry. $20.16. Does that all make sense? Seems like a real pain, but yeah. It's not real common that it goes through that much cycles, by the way, before they just get it out of the store. So let's look at a product that is $120, original price. Goes through a 15% markdown. $20 markup. 30% markdown. And then finally, a 60% markdown. I want you to find the final price. What did we come up with? There you go. 34.272, which will round to $34.27. Very good. May or may not make a profit. At that point, a lot of times they're just minimizing losses. Which actually is a good question because it leads us into our next concept, our final concept. What happens if they don't have this luxury of marking it down and marking it back up and whatever? What if we have something called perishable goods? Well, when we think of perishable, you usually think of food. You know, food can only sit there before, produce is a good one. There are a lot of stores out there that during slow times, they have huge problems managing produce. I've seen some stores that say that they actually have up to like a 40 to 45% waste on produce. Because you have to have the bin full or customers aren't going to buy. I mean, if the bin's half empty, customers are going to just walk past it. But what do customers tend to do with produce? Dig through the pile and find the best looking one. So guess what happens to the not so good looking ones? They sit there and they go to waste. So in produce, you keep it out there as long as you can before it starts to look, it starts to scare customers away. But you know that some of those products you set out on in the bin are never going to be purchased. They're just going to sit there until it's time to throw them out. So you have to allow for that when you're dealing with your markups and all of that. So let's say that you are going to buy, let's talk about apples. And let's say our cost for apples, and this is oversimplifying because I know you're going to buy and sell apples by the pound. You could put in pound of apples or per apples, whatever. It's going to work out the same. I'm just going to simplify it and say that we are going to pay 20 cents per apple. To make a profit, we figure we need 40% markup on cost. Now, at this point, after the first hour of class, whenever you hear percent markup, your ears should be looking for one of two phrases, and you just heard one of them, on cost. That should set off some red flags of, hey, I need to know that, right? So far, that looks pretty standard. It's this next piece that's going to be an issue. You expect 30% to spoil without being sold. In other words, they're going to go to waste, and you are going to recover nothing from them. Let's say you purchase 500 apples. We need to figure out what the selling price is going to be. Only in this case, finding that required selling price is going to require a couple extra steps. Our little table, cost plus markup equals selling price, is still going to be involved, but there's going to be a step or so before, and there's going to be a step or two after. So before we get into that, we need to do step one, which is to find the total cost. We're not going to mark up each individual item anymore because we don't know whether that item is going to sell or not. So we have to mark up the whole batch. So the total cost, 500 apples times 20 cents per apple gives us $100 in our apple cart. Step two is the step we should be really familiar with at this point. That is to mark it up. Where's the 100% going to go? This is based on cost. So 40% goes in for the markup, and we also know we have a total cost of 100 from step one. That's what's going to go under here under the dollar cost. Now, we don't care so much about the markup. We want to know the total selling price that we need to get out of these apples. So we're going to do 100 plus 40 gives us 140% on the selling price. Yes, sir. Got her? Okay. The $100 comes down from step one. So now we don't need the middle row. We're going to find 140 times 100 divided by 100 gives us $140 that we need for a total selling price. So that's the step that we've already done. Next, we have an additional step. Step three, we define the number that are actually going to be sold. Well, we purchased how many? Purchased 500. What percent goes to waste? 30%. Which means we're going to sell 70%. Where did the 70 come from? There you go. That is just 100 minus 30. 30% go to waste, we sold 70%. So what that means is we're going to sell 70% of the 500, which means we're only going to sell, after cross multiply and divide, 350 of them are sold. So now, with that information, we proceed to find, in step 4, find the selling price. So the selling price, we said we needed $140 out of these apples, right? That doesn't get divided up over 500, it gets divided up over 350, because those are the only ones that we're going to sell. The other ones get thrown away with no money out of them at all. So we have to get all of our money out of the 350 apples. So we take that $140 that we found was our selling price from their table. And we're going to divide it by the 350 that are sold, which is going to give us 0.4. 40 cents per apple to sell it for. What do you think? Still better than sharp stick in the eye? This one's getting a little complex. Let's try another example. Let's say that you purchase 50 t-shirts. For $2.50 each. Let's say these are like sport shirts, you know, for the NFL playoffs or something like that. You figure, okay, you expect 20% to go unsold. You have to pull them off the racks and donate them to a thrift store or something. You need to achieve, to break even, a 30% markup on cost. What's the first thing we need to do? Find the total cost. Very good. And we'll do that by 50 t-shirts times $2.50 each is going to be $125. And then step 2 is we're going to do the markup in the table. Very good. Cost plus markup equals selling price. And then the 100% goes here. Yep, cost. 125 is the dollar cost. 30% is the markup. I'll put 130 down here. 100 plus 30. And we're looking for this. So 130 times 25, or 130 times 125 divided by 100 is $162.50, which is a number we will save for later use. That's what we need for our total selling price. That's the total revenue we have to pull in off of these. What's next? Number that you're sold, yes. What percent goes unsold? 20%, which means what percent is sold? 80% is sold. 20% gives us the 80%. Out of 50, which means we're going to sell how many? 40. 80%, 80 times 50 divided by 100 is 40 sold. So then what? The final selling price. Very good. We're going to take the $162.50 divided by 40, which will give us 4.06, basically. $4.06. 4.0625, if I remember correctly. That's a pretty cheap t-shirt, yeah. How you feeling about those? Want to try one? Sure you do. Every now and then I feel like the math pusher. You guys want to try one? Come on, just a little. Just maybe set up the problem, see if you like it. You know? What's that? Oh, we got a whole hour left if I want it. Let's say you're going to purchase donut, or let's do this. Not purchase. You're going to bake or fry, whatever, donuts. We're talking about donuts because, well, I am starting to get hungry. At a cost of 22 cents each. You're going to bake 400. You expect 25% loss. I said loss instead of spoilage because part of that 25% is me eating some of them. If you need to achieve an 80% markup on cost, find that required selling price. I'm going to pause this. So let's start it out. What do we do?
400.
So 400 times 0.22 gives us $88 total cost, correct? Table time. Cost plus markup equals selling price. My table gets sloppier as the night goes on, doesn't it? So obviously 100%, 80%, $88. 180%, looking for that. Forget about that. So 180 minus 88 divided by 100 is 158.40. Very good. So $158.40 is our required total selling price. How many of you got to that point? Okay. Everybody know how to get to that point? Everybody's good? Okay. From there, what's next? Okay. 25% spoil or eaten. So we're looking for 75% of the 400. Now we could also just do 0.75 times 400 if we wanted to, which is going to give us 300 sold. And then, yeah, we find our final selling price, $158.40, divided by 300, gives us 0.53. Yeah, you're correct. 53 cents. What do you think? Everybody feel good about those? Anybody feel totally lost? Anybody want to cry a little bit and go home now? Always? Well, there's one last example I want to show you. Similar to that other one, the one we just did, actually similar to all of them. So let's say we're going to produce 1,200 cookies. Since you're hungry, let's just keep pushing it a bit, huh? At a cost of 15 cents each. We need 120% markup on cost. We figure to survive, we're going to need 120% markup on cost. We expect 20% to go unsold. But here's the kicker. Can sell spoiled cookies. for 5 cents each. This happens a lot in bakeries and stuff. They'll throw their donuts or old donuts and cookies and bread and stuff into a barrel to sell it for bear bait or stuff like that, or for hog slop and things like that. So sometimes you can recover a little bit of cost. So this is going to add an extra step to the end of our process. What's step 1 though? That's still the same. 1,200 times 15 cents, which is going to give us what? Say $180. You're working on it? Sure. Step 2 is still the same. What's going to go in here? 120 is the percent cost, 120 is the markup, which is the selling price is 220%. $180 here, looking for that, cross multiply. 220 times 180 divided by 100 is 396, correct? So we need $396 out of this batch of cookies. Step 3 is still the same. What do we need to find here? How many are sold? What percent spoil? 20%. Yeah, we'll just keep it short with a 20% spoil, which means 80% of the 1,200 are going to be sold. So we're going to sell 960 of them. But at this point, we also need to know the unsold. This is what kind of gets inserted in between step 3 and 4 here. We'll call it step 3A. How many are unsold? Yeah, 1,200 minus 960 is 240 unsold. We'll call it step 3B. What's the recovered amount from the 240? 240 times 5 cents per cookie, which is 12 cents. Yeah, it's almost worth screwing up a calculation, isn't it? Something's off there. Should be $1.20. Yeah, it should be 0.05, right? 0.05. But it's not 12 cents. What is it? $12. That's better. Okay. I was going to say, thank you, $12. I was going to say, 12 cents is a little small. That's only 2.5 cookies. I know I haven't passed up too many free cookies in my life, that's for sure. So we recovered $12. So now in step 4, we need $396. But we don't have to get all $396 from the 960 cookies that sold, because we already get $12 from the spoiled cookies, which means from the ones we sell, we only need to get $384. Now we'll pause there. Everybody understand where the $384 comes from? Any questions there?
Still want to do that stuff right now. Do it at the end.
Well, we have to do that before, because now we're going to do the last step, which is going to be to divide that by the 960 cookies that are sold to get 40 cents per cookie. So you have to take out the amount that you recover from the spoiled cookies before you divide it up to figure out what to charge for the good cookies.
So that's $12, that's for all 240.
That's for all 240 of the spoiled cookies. Yeah, the whole $12. It's almost not even worth the bookkeeping to do it, but you have to. There is a new quiz due tomorrow, which is Wednesday, at 11:59 p.m. There's a new homework that is due 2 weeks from today. Remember, next week is spring break, so please don't try to show up for class next Tuesday. Nobody will be here. Also, 2 weeks from today, which will be on March 16th, correct? No.
That sounds right.
Let me see here.
Yeah.
March 17th, there we go, is going to be Unit 2 test. Like I said, I apologize for giving you a good solid 2 weeks to forget everything we've learned in the last 4. But that's just the way the calendar goes.
So the homework's not due tomorrow, or